Question 3 drops a bit of a sigma notation on our lap. So let's analyze the sigma notation. Alright, so this sigma over here has an infinity up there, which means it can be a converging pattern depending on the values of x. And that's what they're actually asking here. For which values of x will this thing exist, or will this thing converge? So I can't really get the number of terms, but I have the pattern rule. So I'm going to sub this bottom number in to get my first term, and then I increase it by 1 and I get my second term, and I'm going to increase it by 2 to get my third term. So let me show you how to do that. So I just grab this bottom number and I put it in this variable's place, k. So I swap k with 1, and there's term 1. Now anything to the power of 1 doesn't change, so I can essentially get rid of this 1. And then to get the second term, I just go up by 1 here with bottom number and sub that in like last time. So the second term will be bracket 4x minus 1 bracket to the power of 2. And then I sub k equals 3 in there, and I'm going to get term 3. And now I've got my first 3 terms. Now for which values of x will this thing exist, aka the sum to infinity? So let's grab our sum to infinity formula and have a poke at it. So with my sum to infinity formula, to actually use this formula, this ratio here must be smaller than 1, but at the same time bigger than -1. So that's the logic of this question. That's what everything revolves around. So I'm going to want to get my ratio and model it to be smaller than 1, but bigger than -1 at the same time. So let's go get our ratio quickly. So our ratio is obtained by saying term 2 over term 1. So I'm going to replace term 2 with this thing, and I'm going to replace term 1 with this thing. And now I've got to simplify that. Okay, to simplify that I can use exponent laws. So this bracket at the bottom has an exponent of 1, and 2 minus 1 will just give me 1, so it's this bracket to the power of 1. Or you can take this approach towards it. If you're squaring something, it means you're multiplying it by itself, and then one of these brackets will cancel with one of those, and that leaves us with a ratio of 4x minus 1. We don't need these brackets anymore because it's not being multiplied by anything. Okay, now this ratio, I want it to be in between 1 and -1. So I just model it like that. I just replace this r with this over here. So you can see I've just replaced that r with what the ratio actually is. And then I solve for x. So I'm going to plus 1 everywhere. And then -1 plus 1 is just 0. -1 plus 1 is 0 again, so I'm only left with 4x in the middle. And 1 plus 1 will give me 2. Now I almost have x on its own. I just need to get rid of this 4. So I divide all 3 sides here by 4. And then I'll just simplify a little bit. 0 divided by 4 is just 0. 4 divided by 4, they cancel, and you're just left with the x over there in the middle. 2 over 4, if you pop that in the calculator or simplify it, it gives you a half. So when x is in between a half and 0, we will get the sum to infinity, and this thing will exist. And then one more small thing about the sum to infinity. Your ratio can never be 0, so that will affect our answer. So the ratio we got here, 4x minus 1, cannot equal 0. So I'm going to model that separately. So the ratio cannot equal 0. And then I take this 1 over, it becomes plus 1. And I divide both sides by 4. And I get x cannot equal a quarter. And then these 4 very hard fought marks will firstly come from the ratio. The condition that the ratio is in between 1 and -1. Your answer, as well as the exclusion of a quarter.